My dear class 10 students, now I am going to deliver before you a PowerPoint presentation on chapter 2. The topic of the chapter, acids, bases and salts. So the main objectives of this lecture about definition of acids and bases we are going to discuss. The definitions are important because if we discuss the definitions, then the properties, mainly the chemical properties of acids and bases, become easy. In the next one, we will discuss about acid-base indicators. That means here we consider some special type of substances which we can use to detect the presence of acid and bases in solution. In the third point, we will discuss about chemical properties of acids and bases. We know that acids and bases are very corrosive and they react with metals, metal oxides, non-metallic oxides and react with each other and form salt. So here we'll discuss about chemical reactions of acids and bases in detail. So next point, it is about strength of acids and bases. So here we will discuss about the factors on which the strength of an acid and base depends and how can we determine the strength of an acidic solution and a basic solution. So there are some technique and there are some scales. With the help of that we can determine the strength of an acid and a base. Mainly here we discuss about pH scale. The last one, it is about salts, and salts we can prepare by reacting acid with bases. And mainly here we consider the family of salts, different salts, and the pH of salts, and about one interesting type of salt, the hydrated salt. That means we are going to discuss about water of crystallization. So here let us discuss the introductory part now. Acids and bases are very important chemical substances and some are natural and some are man-made. So the word acid, it is derived from the Latin word acidus and the meaning is sour. And the substances, those are bitter in taste and feel soapy on touching with our finger, are known as bases. So one example of base, it is washing soda. We use in washing purposes and it is a sodium compound, sodium salt. So there are some natural acids and already you know about hydrochloric acid. It is present in our body. It is secreted by the lining of our stomach and it helps in the process of digestion. The next acid, it is citric acid and ascorbic acid. And citric acid and ascorbic acid, it is present in lemon and oranges. And dilute acetic acid, it is present in vinegar. Vinegar you have in your kitchen, and it is now acetic acids. It is CH3COOH. It is organic acid. That means it is sometimes it is known as ethanoic acid also. The common name is acetic acid. It is present in your vinegar. And another one, tartaric acid, it is present in tamarind, and oxalic acid, it is present in your tomato. So these are some food items where we have natural acids and these acids are present in these items. So mainly here the ascorbic acid, it is also known as vitamin C, and it helps, and you know that vitamin C helps to increase our immunity, is uh, very useful the ascorbic acid, it is very important for us. So we should eat lemon and orange regularly so that we can get ascorbic acid regularly. So next it is about different definitions of acid and bases. So now definitions are very important here, because if we want to study the chemical properties of acids and bases, it depends on the definition part. That means the why some acid react with, say, some distinct substance and form some form some product and byproduct, and why are some other substances, why these are not reactive towards that particular substance, we can easily explain with the help of definition part. So the definition part, though it is not given in your textbook, but these are important points. That's why I want to discuss the definition one by one. Mainly we concentrate in three definitions. So that's why I am going to discuss the definition parts here. So now let us consider number one definition, and it is Arrhenius definition. In Arrhenius definition, we consider those substances which, when we dissolve in water, which release H plus ion, hydrogen ion, and H plus, it is also known as proton. For example, hydrochloric acid in sulfuric acid. Now see the formula. In both the cases, that means hydrochloric acid, sulfuric acid, we have hydrogen. And when we dissolve this acid into water, then there is release of H plus ion. And the strength of one acid it depends on the amount of hydrogen ion that are released by that particular acid. So according to Arrhenius, proton releasing compounds are known as acids, and the bases are those compounds which release OH minus ion in water. The OH minus ion, it is known as hydroxyl ion or hydroxide ion. So some examples, it is sodium hydroxide and ammonium hydroxide. Here sodium hydroxide, when we dissolve in water, release Na plus and OH minus, and ammonium hydroxide NH4 plus and OH minus. Now sodium hydroxide, it is a strong acid, whether ammonium hydroxide, it is a weak acid. So why we call sodium hydroxide strong and ammonium hydroxide weak? It is due to the amount of hydroxide ion that are released by this particular bases. So since in case of sodium, the release or dissociation of sodium hydroxide in water, it is very fast, and release of hydroxide ion, amount of hydroxide ion, it is more. Therefore we call sodium hydroxide a strong acid, whereas in case of ammonium hydroxide, it is less. That's why we call ammonium hydroxide, we consider ammonium hydroxide as weak acid, weak base. Next definition, it is about Bronsted Lowry definition. Here we consider acids as the compounds which can donate proton to other molecule. For example, acetic acid CH3COOH, which is present in your vinegar, when we dissolve in water, then it donate one proton to water, and water become hydronium ion. So here, since acetic acid donate proton easily, therefore it is considered as acid. Now according to this definition, bases are opposite one. That means bases that can easily accept protons are called, that means compounds that easily accept protons are called bases. So for example, we consider ammonia molecule. When we dissolve ammonia in water, then the ammonia molecule will accept one proton from water and become ammonium plus, that means ammonium ion, NH4 plus. In the above reaction, ammonia has accepted one proton from water, and therefore it is considered as base. That means, according to Bronsted Lowry definition, proton donors are acids and proton acceptors are base. So next, the third one, it is Lewis definition. Here we considered acids and bases not in terms of proton donor or proton acceptor or proton release, hydroxide ion release. We consider here the definitions, that means acids and bases, as electron transfer. That means in terms of electron transfer, we consider this definition. Now here acids are the substances or molecule or ion that can accept electron. That means electron acceptors are acid. So main example, it is electron deficient molecules are considered as acid according to this definition. Here we have BF3 and aluminium chloride. BF3 means boron trifluoride and aluminium trichloride. In both the cases, the central atom, it is boron in case of BF3 and aluminium in case of AlCl3. So here the central atom, around the central atom, there are only 6 electrons. Since we have 3 BF3 bonds in case of BF3, and in case of aluminium we have 3 AlCl covalent bonds. Then one bond means 2 electrons. Since we have 3 bonds, that means 6 electrons are present. But according to law of octet, for a stable molecule, the number of electrons around a central atom should be 8. But here it is 6. Therefore, this type of molecules are considered as electron deficient molecules. So according to this definition, electron deficient molecules are considered as acids since it can easily accept electron from other molecules. Now what are bases? So according to this definition, bases are the molecule or ion which can donate electron to other molecules. For example, if we consider ammonia molecule, in ammonia there are 3 NH bond and lone pair it is present on nitrogen atom. Since nitrogen it is present in group 15 and in outer shell there are 5 electrons, and out of these 5, 3 bind with 3 hydrogen and form 3 NH bond, and other 2 electrons remain as lone pair. Now this lone pair electron in the ammonia molecule, it can easily donate this lone pair electron to other molecules. Here we have BF3 molecule, and already it is known to you BF3, it is electron deficient molecule. So it can easily accept the electron that are released by ammonia. So here in the above case, ammonia acts as base since it donates electrons, and BF3 molecule, it is considered as acid since it accepts the electrons from NH3. So all these 3 definitions are very important, and in higher secondary level again you will have to study and about these definitions. Now the properties of mainly the chemical properties now become easy since we already considered these definitions. Now let us consider the next topic, and it is about different types of acid-base indicators. So indicators are the substances that can be used to indicate the presence of acidic substance and basic substance that are present in a solution. Now say we consider a solution, it is unknown one, and we have say 3 solutions and all are unknown solution, and you have to identify the acidic and basic solution or neutral solution. So how can we detect, how can we identify the solutions? So for that purpose, we need some substances so that we can easily detect. We can't test all the chemicals. Chemicals are dangerous one. Some are very toxic, so we can't test it. So in case of that purposes, that means when we have to identify the unknown substance, acidic substance or basic substance, then we use some substances which are considered as indicators. That means it indicates the presence of acid and base in the solution. Now there are mainly two types of acid base indicators. Now the first one, it is natural one, and natural acid base indicators we can extract it from nature only, from natural substances. So for example, litmus paper or litmus solution. So litmus, it is extracted from the plant lichen, which belong to the division Thallophyta. So we have two types of litmus paper or solution. One is red litmus paper, another is blue litmus paper. So if we add 1 or 2 drop of acid into blue litmus paper, the blue litmus turns into red. But if we add basic substance, basic solution into blue litmus paper, there is no color sense. Again, if we take red litmus paper and add basic solution, then the color become blue. The color of litmus paper become blue. Again, if we add acidic solution in red litmus paper, there is no color changes. That means the color of litmus paper become different one when we add acid or base. That means litmus paper we can easily use to detect the presence of acids and base in a given solution. So other examples are red cabbage leaves, then turmeric, and colored petals of some flowers we can use as acid base indicators in the same manner. Next, it is synthetic indicators, and synthetic indicators we can synthesize in the laboratory by chemical reactions. Mainly there are two examples of acid base indicators, and number one it is methyl orange and number two it is phenolphthalein. Now if we add methyl orange indicator in acidic medium, the color of the solution, the color of the indicator become red, and if we add into basic solution, then color become yellow. Again, in case of phenolphthalein, if we add in the acidic medium, then there is no change in the color of the solution. But if we add into basic solution, then color become pink. That means by using these two synthetic indicators, we can identify or we can detect the presence of acidic substance and basic substance in a solution. Now there is another type of indicator. In the first, in case of litmus paper and in case of methyl orange phenolphthalein, we consider the color sense in the indicators or in the solution. But there is another type of indicator in which there is no color sense, but there is sense in odor of the indicator. So this type of special type of indicators are known as olfactory indicators. Some examples, it is onion and vanilla, clove. These are some examples of these olfactory indicators. So here the main important points, you try to remember the name of different indicators, acid base indicators, natural as well as the synthetic one, and the color of different indicator in acidic medium and basic medium. So you make one list of color of different indicator in acidic medium and basic medium. So next topic it is about chemical reactions of acid and bases, and it is very important one. Uh, so here we will discuss first. We will discuss about reaction of acids and bases with metals. So we know that acid and bases, these are corrosive one. So it readily react with metals and release hydrogen gas. Now both acids and bases react with metal and releases hydrogen gas. For example, if we consider zinc hydrochloric acid, that means if we consider zinc metal and we add so now this is the activity that is given in your book. So here in the test tube we have zinc metal and we have added some hydrochloric acid in the metal, and the test tube it is connected to one band tube with a cork, and that band tube it is dissolved in a soap solution. So here when we add acid into the metal, the solid part it is metal, uh, we can see the bubbles, and these bubbles are due to release of hydrogen. Now these gas bubbles can pass through the delivery tube, that means this band tube also known as the delivery tube, and in the soap solution we can see the bubbles. Within the bubbles we have hydrogen gas. Now if we keep one burning candle there, then the hydrogen gas it burns with pop sound. So with this type of activity we can identify the gas that are released when we add acid into metal. Especially here it is considered zinc metal. Now in case of base also the same type of reaction will occur and there is release of hydrogen gas. So you try to remember the name of the gas that is released when we add acid and base in metal. So metal reacts with acid and base and it forms some salt. Here the salt is zinc chloride, ZnCl2, and the second one is sodium zincate. Try to remember the formula of the compound. It is Na2ZnO2. So both the reactions are important, and try to remember the formulas. So next one we consider the reaction with metal carbonates and metal hydrogen carbonates. So here main thing, the metal carbonates and metal hydrogen carbonates both are base. Mainly these are mild base, and we know that acid when react with base forms salt. Now this case is similar here, since both the carbonate, metal carbonates and metal bicarbonates or hydrogen carbonates are basic in nature. So acid react with these carbonates and form salts and release carbon dioxide and water molecules. So these are two reactions, and here sodium carbonate and sodium bicarbonate both react with hydrochloric acid and form the common salt sodium chloride, NaCl, and water carbon dioxide. So how can we remember this balance equation? So in case of sodium carbonate, uh, the release of sodium chloride it become 2, that means the salt sodium chloride salt it is 2, and in case of sodium bicarbonate it is 1. So try to remember the balanced chemical equation for both the reactions. So next it is reaction of metallic oxides with acids. Now metallic oxides are basic in nature. So if we add acid into metallic oxide, then again there is formation of salt. So here if we consider, say example, copper oxide, it is copper, it is metal, copper oxide it is metallic oxide, react with hydrochloric acid and form salt, and it is CuCl2 plus water. That means it is like your acid-base reactions. Since now it is the important point, since metallic oxides are basic, so the reaction of acid with metallic oxide, it is same with base. That means with base, acid forms salt and water. Here also with metallic oxide, the acids form salt and water. So next, reaction of non-metallic oxide with base. Now here again the interesting point is, since non-metallic oxide, for example carbon dioxide, sulfur dioxide, these are non-metallic oxide. Since non-metallic oxides are acidic in nature, so it can easily react with base and form like normal acid and form salt and water. So here example is your non-metallic oxide, it is carbon dioxide. It reacts with a base calcium hydroxide. Since it contains OH, it is hydroxide, calcium hydroxide, it is a base. It reacts with non-metallic oxide carbon dioxide and form calcium carbonate, it is a salt, and release water. So these two reactions are very important because here we consider metallic oxides as acidic, as basic one, and the non-metallic oxides as acidic one, and it reacts with acid and base respectively and form salt and water. The next one, the next reaction, it is very important reaction, and it is reaction of an acid with a base. Now we know that both acid and base, these are corrosive one, these are highly reactive. So what happens when we mix this acid and base? So when we add acid into base, then there is formation of salt. And if we consider the reaction of acid with base, this reaction also known as neutralization reaction. Since the acidic property of acid, it is neutralized by your base. So one example here it is given, sodium hydroxide, it is a strong acid, and hydrochloric acid also, it is strong acid. And when we mix these two, acid and base, that means aqueous solution, when we consider, then we will get sodium chloride, the common salt, and water molecules. So here there is formation of salt. That means already we discussed about chemical properties of acids and bases. Mainly there are 5 reactions, and now summary of some important points about acids and bases. So number 1 important point, all acids generate proton and all bases generate hydroxide in water. Example, hydrochloric acid, it produces hydronium ion, and sodium hydroxide also, it produces your OH ion. So here one important point, if we dissolve the base in water, then it is soluble in water, then that type of bases are known as alkali. Mainly the sodium hydroxide, calcium hydroxide, that means the metals that are present in group 1, group 2, these are soluble in water, so these are considered as alkali. That means instead of base we can use alkali also. It is meaning is same. That means water soluble bases are called alkalis. The next point, it is about the process of dissolving acid and base in water. So what happens if we add acid and base into water? Since acid is strong one, base also strong, so what happens when we add? So the process of dissolving an acid or base in water, it is highly exothermic. Exothermic, the meaning of exothermic reaction, it is That means heat is released when we add acid and base into water. The container becomes hot. So therefore, we should take extreme care when we mix acid and base into concentrated acid and base in water. So always, and remember, it is very important point, always add acid to water. Don't add water to acid. And when we add acid to water, we should add with constant stirring. So it is very important point. So it is warning for you when we have to do some experiment in the lab. So always you add acid to water, not water to acid. Now what happens? Why your container become hot when we add acid and base in water? So if water is added to concentrated acid, the heat generated, it may cause, that means it become very hot, and the mixer it may cause burns, and the container may break due to generation of local heat. That means since high amount of energy it is released during this process, it is about strength of an acid and a base. So how can we determine one acid it is strong acid, another one it is weak acid? On which factor it depends? So already we discussed about definition part, and we, according to Arrhenius concept, the proton releasing compounds are considered as acids and hydroxide ion releasing compounds are considered as base. So when we dissolve these compounds in water, then if more amount of hydrogen ion and hydroxide ions are formed, then these acids and bases, these compounds are considered as strong acids and strong bases. So how can we determine the hydrogen ion concentration and hydroxyl ion concentration in solution? So here we consider one scale which is known as pH scale, and this scale is used to measure the concentration of H plus ion and OH minus ion in solution. The range of pH scale, it is from 0 to 14. So if we have a solution, and with the help of pH scale we can measure the pH value of the solutions. So in our laboratory we have pH paper and pH meter also. So with the help of pH paper and pH meter we can determine the strength of acid, that means pH value of acid and basic substances. So if pH value it is less than 7, then the solution is acidic. If pH value is more than 7, then the solution it is basic. And if it is equal to 7, then the solution it is considered as neutral solution. Now the importance of pH in everyday life. Now the pH range of our body, it is 7 to 7.8. That means within this pH value, within this range, our body works. That is, within our body there are lots of chemical reactions. Always there are taking place lots of chemical reactions, and for that chemical reactions the pH value should be from 7 to 7.8. The pH value of rainwater, it is less than 5.6. That means rainwater, it is consists of, that means in rainwater we have some acid, and due to presence of that acids, in normal water the pH is 7, and due to presence of this acidic substance, mainly it is carbonic acid, sulfuric acid, the pH value of water it decreases and become 5.6. And the pH value of our mouth, that means after eating, the pH value become less, that means our mouth become acidic one. So we should use so toothpaste which is basic in nature, so to neutralize our pH value, that means to neutralize our pH uh, within our mouth. So if the pH value become less than 5.5, then the tooth decay starts. So be careful, and always you brush your teeth after eating, so that we can maintain the pH value within our mouth. And another fourth important point, it is about some acid that are released when uh, we consider the bee sting and stinging hair of nettle leaf. Then what happened? Methanoic acid, the formula is HCOOH. That means it is the simplest organic acid, and the methanoic acid it is released, and it causes some burning and irritation feeling. So we can get relief from that irritation by adding some basic substance like baking soda. Baking soda, it is a mild basic substance, mild base. So we can use baking soda to get relief from that type of irritation. And another plant also there, which is known as dog plant, and here we can add the leaf of dog plant also for the relief. So next one, it is about salt, and we know that when acid react with base, and there is formation of salt. So mainly we have three types of salt, and if we consider the pH value of salt, then we have three types of salt. And if we consider the metals, that means the basic part and acid part of the salt, and then we have different families of salts. For example, here we have hydrochloric acid and sodium hydroxide. When we react to these two, then we will get sodium chloride. And if we consider reaction of sodium hydroxide with sulfuric acid, then we will get sodium sulfate. Both are the sodium salt. Therefore, these two salts are belong to sodium family. And if we consider, say, hydrochloric acid, reaction between hydrochloric acid and, say, your sodium hydroxide and formation of sodium chloride, then hydrochloric acid and, say, calcium hydroxide, then we will get calcium chloride. Then ammonium hydroxide and hydrochloric acid, then we will get ammonium chloride. So in all the cases, the acidic part, it is chloride. So we can consider these three as these three salts belong to chloride family or chlorine family. So like this, we can consider the salts. Some salts are belong to some metals, some salts are belong to some non-metallic part, that means acidic part. Next, depending on the pH value of different salts, we can divide the salts into three types. One is the acidic salt, and the pH value for acidic salt, it is less than 7. The another one, it is neutral salt, where the pH value it is equal to 7, and the next is the basic salt, where the pH value is more than 7. So the examples are here. So hydrochloric acid and sodium hydroxide, when combined, both are strong. That means hydrochloric acid also strong, sodium hydroxide also strong. Therefore, we will get one salt which is known as neutral salt, sodium chloride. since both are strong. So next it is if we consider reaction between hydrochloric acid and ammonium hydroxide. Here hydrochloric acid it is strong acid, but ammonium hydroxide it is weak base. So the salt it is ammonium chloride, and this salt it is considered as acidic salt, and the pH value it is less than 7. Now if we consider reaction between a weak acid, for example ethanoic acid or acetic acid, which is present in your vinegar, and it react with sodium hydroxide, it is strong base, then we will get one basic salt. Here your salt is sodium acetate. Now we have mainly this type of salts which are given in your book, and we are going to study about these salts in detail. And the first one it is sodium chloride, and we can prepare other salts, other chemicals, baking soda, bleaching powder, washing soda from sodium chloride. So sodium chloride it is a raw material for many chemical substances that are used in laboratory. So first one we consider sodium hydroxide. So sodium hydroxide it is a base, and it is a very important chemical in our laboratory. So sodium hydroxide can be prepared with the help of chloralkali process by passing electricity through an aqueous solution of sodium chloride, which is also known as brine solution. And after electrolysis, sodium hydroxide will form along with chlorine gas. It is produced at anode and hydrogen at cathode. So this is your reaction, sodium chloride plus water, that means electrolysis in aqueous solution. Then we will get sodium hydroxide, chlorine and hydrogen. So the chlorine and hydrogen also we can use in different purposes. Chlorine also it is very useful chemical. We used in water treatment and polyvinyl chloride synthesis, PVC synthesis, and also we can use as disinfectants and pesticides, and CFC means chlorofluorocarbon. In the preparation of chlorofluorocarbon also we can use chlorine. The next is hydrogen. Hydrogen we can use in the preparation of ammonia, and for in the manufacturing of fertilizer we can use hydrogen. So next it is hydrochloric acid. Hydrochloric acid we can use to clean the metals, mainly steel, ammonium chloride. In the preparation of ammonium chloride we can use hydrochloric acid, and in the preparation of many medicines we use hydrochloric acids, and in cosmetic also, in the preparation of cosmetic also we use hydrochloric acids. So these are different uses of the products and byproduct of electrolysis of sodium chloride, the common salt. Now bleaching powder. Bleaching powder it is the common chemicals we use to clean our floor. So here the formula it is, though the actual formula it is not given here, the simplest formula it is CaOCl2. Here we can prepare bleaching powder by passing chlorine gas through calcium hydroxide. That means it is called slack lime. That means by passing chlorine gas through slack lime we can prepare bleaching powder. So bleaching powder already it is known to you about the uses of bleaching powder. We can use in the textile industry, paper factories and laundry, and sometimes it is used as oxidant. Oxidant means oxidizing agent in many chemical reactions, and it is as disinfectants also we can use bleaching powder. Next is baking soda. Baking soda, the formula is HCO3, that means sodium bicarbonate or hydrogen carbonate. It is a mild non-corrosive base. So here we can prepare sodium bicarbonate. Preparation, it is important for you. So how can we prepare baking soda, and formula also important. So baking soda we can prepare from mainly from sodium chloride and ammonia, and by passing carbon dioxide gas and passing water vapor, that means water in water, we can prepare it, and the byproduct, it is ammonium chloride, a salt will form along with sodium bicarbonate. Now during cooking we can use baking soda in cooking for cooking purposes. Now during cooking, what happens when we heat it or when we dissolve in water, then sodium bicarbonate is converted into your sodium carbonate. So here sodium bicarbonate we can convert it into sodium carbonate. So main uses of baking soda for making baking powder. So what is baking powder now? Now if we add small amount of tartaric acid, it is a mild acid. If we add tartaric acid in baking soda, then baking powder will form. So now the baking powder we can use in cooking purposes, and there is release of carbon dioxide gas, and that carbon dioxide makes your bread or cake this soft and spongy. So next we can use baking powder or baking soda in the preparation of antacids, and also we can use it in the preparation of soda acid fire extinguisher, we can prepare it. So these are the uses. We can make spongy cake, we can use in fire extinguisher, and in the antacid we can use this baking powder and baking soda. So next it is about washing soda. So washing soda, now see the formula. It is also sodium salt, that means we can prepare from sodium chloride. Here it is from sodium chloride we can prepare sodium bicarbonate. From bicarbonate we can prepare, by heating it we can convert it to sodium carbonate, and if 10 water molecules are present along with the sodium carbonate, then we call it decahydrate. Since 10 it is decahydrate sodium carbonate, it is known as washing soda. That means the formula, it is important. It is decahydrate sodium carbonate, it is known as washing soda. So if we consider sodium carbonate and add water, then we will get decahydrate sodium carbonate washing soda. So what are the uses of your sodium washing soda? So in glass or soap and paper industries we can use is washing soda, and in the manufacturing of sodium compounds like borax, it is a sodium compound, and in as cleaning agent also we can use, and to remove permanent hardness of water, the spelling it is wrong one, so correct it, it is permanent hardness of water. That means to remove the hardness, there are two types of hardness of water. One is temporary, another is permanent. So it is not easy to remove permanent hardness, and we can easily remove temporary hardness by boiling or by applying, say, calcium oxide or calcium hydroxide. But for permanent hardness, it is not easy to remove the permanent hardness from water. So in this case, we use washing soda to remove the hardness, permanent hardness of water. So the last topic, it is water of crystallization. So what is water of crystallization? So the definition, it is now carefully you see the definition. It is Water of crystallization is the fixed number of water molecules chemically attached to each formula unit of a salt in its crystalline form. So that means if we consider, say, copper sulfate, if copper sulfate CuSO4, that means only copper and sulfate ions are there, and we have a crystal, then the color of copper sulfate, it is white. But if some water molecules are present in the crystal, then the color of copper sulfate becomes blue. So these 5 water molecules that are present in copper sulfate crystal, it is known as water of crystallization. So there are some examples of salts where we have water of crystallization, and number 1, it is gypsum. Calcium sulfate, it is dihydrate, 2 molecules of water are present in the crystal. Then plaster of Paris, calcium sulfate hemihydrate. Then washing soda, already we discussed, sodium carbonate decahydrate, and copper sulfate pentahydrate. So copper sulfate pentahydrate, this is the crystal structure of copper sulfate pentahydrate. Now the green color, it is ball and stick model. The green color balls, it represent your sulfur, and the orange color big balls, these represent copper atoms, and the small red color balls, these are oxygen molecule, and the silvery color small balls, these are hydrogen. So this is the ball and stick model of pentahydrate copper sulfate, and you can see the small water molecules here. 4 are visible here in the structure, 4 water molecules, and another one is from other side, we can see that part. So 5 water molecules are present in the crystal structure, and these water molecules are known as water of crystallization. If water molecules are present in the crystal, then the color, it is blue in color, and if like this, and if water molecules are not present in the crystal, then the color of the crystal, it is white. So water of crystallization, it is important point here. So these are the examples of compounds or salts in which we have water of crystallization. So this much for today. So at home, you try to remember the different formulas of different salt, mainly these hydrated salts, and uses of your salts, mainly baking soda, washing soda, then your sodium hydroxide. So how can we use chlorine and hydrogen? That means electrolysis of sodium chloride, it is important one, and the definition of water of crystallization, it is important. So try to remember the formulas and reactions for different chemical reactions, and at home again you study, and if you have any doubts, then clear it. And now we have one WhatsApp group also, so you can ask me if you have any doubt. So thank you, and this is the end of my presentation.